I'm here to tell you about a wonderful place that many of you maybe haven't heard of called Titan. Titan is a giant ice moon out in the outer solar system orbiting the planet Saturn. And Saturn is 10 times further from the sun than the Earth, okay? So it's like really cold out there. At the same time, Titan is made mostly out of water. But it's, like I said, it's very cold water, so the water at the surface is all totally frozen and sort of forms the bedrock. However, we now understand that if you drill down about 100 kilometers beneath the icy crust, Titan's interior contains a liquid water ocean that has 10 times more water than the entirety of all the oceans on the Earth. What's particularly exciting about Titan, among the other ocean world moons in the outer solar system, is that Titan also has the key elements we think you need for life, particularly carbon. So this picture you see here of Titan is kind of fuzzy because Titan is the only moon in our solar system with an atmosphere. And the air, the atmosphere on Titan, is partially made of methane, which is the same stuff in your natural gas stove that burns. But on Titan, there's no oxygen to burn. That methane composition CH4 gets hit by solar ultraviolet. It busts up those methane molecules and they reassemble themselves into more and more complex hydrocarbon molecules. What happens then when you take all that carbon and you then mix it with the liquid water ocean, either when that water ocean oozes out onto the surface in what we call a cryovolcano, or when a giant comet slams into the surface of Titan and melts a bunch of that surface ice to create a melt pool. We think that when you mix those two, the organic material from the atmosphere and the liquid water, you get a primordial soup, perhaps similar to the what we think may have occurred on early Earth to form life. We do not know how life formed on Earth. It happened 4.5 billion years ago, okay? So the record of that has been lost to geology that has destroyed it over time. But we think that if we were to visit Titan, we might be able to actually measure the composition of that primordial soup and perhaps tell what some of those processes were that may have led to life, and whether, in fact, they were able to build up simple self-replicating molecules there on Titan. That led me to develop my space mission called Dragonfly. I have a little model of it here, but the real vehicle is actually really big. It's like 4.5 meters long, weighs a ton, a metric ton, and it's going to land there on Titan using its rotors to fly around, and we're going to drill into that formerly liquid water, now solid ice, of course, and we're going to measure it. We're going to look for, does it contain amino acids, which are the building blocks of the proteins that build your body? Does it contain lipids that create the membranes that line your cells? And does it create like nucleobases that go to produce DNA and control life inside the processes inside your body? So we, funded by NASA, we are going to launch in 2027, and we will land on Titan in 2034. And hopefully by then, we'll be able to give you the first hints of how life may have formed on Earth and whether or not we're alone here in the solar system. Thanks.